Hello and welcome back to Lean on Success, where process improvement is self-improvement. My name is Ben. I'm a Lean Six Sigma Master Black Belt, and today I'm going to present statistical evidence why short men are awesome. So I hope you're ready for that. Now, very important, you cannot make a valid statistical conclusion until you have properly addressed bias. So let me just go ahead and put the biases out there, okay? I'm a short dude. All right. I have always been a short dude. I'm 5 feet 7 inches tall. I was 5'7.5" at some point. Somehow I magically lost a half an inch somewhere along the way. Not really sure what's going on with that. Maybe I need to go to the chiropractor, get stretched out again. I don't know. So just want to put that disclaimer out there. I'm not tall. I've never been considered to be tall. I'm 5'7". But I think that you will see that although this is coming from the perspective of a short man, the evidence that I'm going to present to you today is going to be indisputable. So let's jump right in. Okay, so before we get into why short men are awesome, I want to use a different example to kind of set the table for the statistical analysis we're going to do today. So what I want us to consider is the annual rainfall in the state of Florida by locale. Now, I live in the state of Florida. I've been a Florida resident a little over 15 years, and it gets pretty rainy here. So I have here a list of some of the more popular locales in the state of Florida by population, and I have a list of what the rainfall is in each of those locations. So you can see here that the list is organized alphabetically, and I have the annual rainfall in inches across all of these locales. Now, if you just casually glance, you'll see that the state of Florida apparently must be a pretty big state because these particular outputs or these particular rainfalls vary pretty widely from one city to the next. Now, again, because the amount of the rainfall in each city varied so much from one city to the next, just taking the average of all of those totals don't really give you a clear picture of what's really happening in the state of Florida. So what we can do, instead of just relying on the average as a singular number, we can break up each of those individual rainfalls into buckets of equal size and then look at the shape of the data that way. So as you see here, I've got some buckets arranged here at the bottom, and I'm starting at the low end of the rainfall, which is 37 inches, and ending at the high end of the rainfall that we saw, which was a little bit over 70 inches. Now, if you notice, each bucket is equal in length. So 37, 40.5, 3.5 inches wide, if you will. So what I can do is start to arrange all of those individual data points and filter them into each of these buckets. So as you see, everything's kind of dropping in. I've got all the data points for the rainfall from each city falling into these buckets. Now that I have the data arranged that way, I can draw columns like this to represent how many of each of these particular data points fall in each bucket, otherwise known as the frequency. I want to see what the frequency is in each bucket. Now, it's very important that these buckets are of equal size so that you are not skewing your data unnecessarily. Now, when you draw a set of columns like this to represent data that's in buckets of equal size, we call that a histogram. In this case, because we've got a histogram that represents data, we actually can call that histogram a data distribution. All right, because we've distributed the data across different buckets of equal size. So as you see at the top of the center of the screen, that was the distribution of data that we just saw in the rainfall data that we just covered a minute ago. Now, it's important for us to know that you can look at the shape of data and it can tell you certain things about the characteristics within that data. In other words, there are many different types of data distributions that exist that can tell you or give you clues about what type of data you have. However, there is a particular type of distribution of data that represents that age-old bell curve that we have seen many times before, and we call this the normal distribution. All right, that's the name for a distribution of data or a histogram that roughly resembles or closely resembles a bell curve. All right, so what's the big deal with these normal distributions? Well, the interesting thing is, if you have a normal distribution of data, you can make certain assumptions about how that data falls into its respective buckets based on standard deviation. So you remember in our previous episode, we talked about standard deviation and being able to measure variation in a process. Well, if you have a normal distribution, if your histogram is a nice symmetrical curve or represents a nice symmetrical curve, if we divide this up into standard deviations, so you've got, your standard deviation is here. So this is plus 1 sigma, or 1 standard deviation away from the average, 2 standard deviations away from the average, and so forth. What we can assume with this data is that 68% roughly of all of the data that's contained in that histogram or in that data set falls within 1 standard deviation of the average. So stated simply, all of the data that falls within the buckets that are within 1 standard deviation, either above or below the average, represents 68% of the total amount of data that's in this particular data set. Now we can stretch that out even further and say that 95% roughly of all of the data in the data set falls within 2 standard deviations. So if I just look at the data that's from here to here, this is 95% of the data. If I go out further, I see that 99.7% of all of the data points in a normal distribution fall within 3 standard deviations. So what does all this have to do with short men? I thought this was a video about short men. I'm so glad you asked. Now here we're going to create an operational definition, and specifically we're going to define a short man as a man that is under 6 feet tall. Okay, so regardless of what your particular rankings are, we're going to say that short men for the purpose of this exercise is any man that is under 6 feet tall. All right, so firstly we need to understand that the average height of a man in the United States is 5 feet 9 inches tall. And your sigma, or your standard deviation, is 2.8 inches. Now if we draw that same curve again, what we can see is we have an average of 5'9", that's right there in the middle of our data. If we go out 1 standard deviation, or 2.8 inches above and below the average, we see then that 1 standard deviation down is 5'6", 1 standard deviation up is 6 feet. So based on what we just talked about, we know then that 68% of all of the data in the data set for men's height is within 1 standard deviation of the average. To say that simply, 68% of men in the United States are between 5'6" and 6 feet tall. Now, what we then can assume further is, if we know that 68% is represented here, we then know that the 32% that's left over are in these buckets. So if we round up, we see that 16% of the data, or of men's height in this example, is falling above the 6 foot bucket, and then 16% of the men's height are falling below the 5'6" bucket. So based on this, and the fact that we know that men's height follows a normal distribution, based on the fact that we know that the average height of a man is 5 feet 9 inches tall, and that the standard deviation is 2.8 inches, we then can conclude that 84% of men in the United States are short by our definition. So why are short men awesome? Because we're 84% of the population. So all the short guys out there, if you're under 6 feet tall, give yourselves a pat on the back. You can stand up a little bit straighter and know that you still matter. Okay, so that's it for today's episode. I kept it short and sweet for everybody. Get it? Short and sweet? Ha ha! Dad jokes. So in our next episode, we're going to talk about why good men are hard to find. I'm going to have yet another case study to show you and explain to you why the dating market is as difficult as it is these days. Thanks so much. If you love this video, please hit that like button. Again, if you hated it, please hit the like button or the unlike button, whichever you want. Make sure you subscribe to the channel. Thanks so much, and I'll see you next time.